This is Zhice from ShanghaiTech University. In this talk, I'm going to introduce a new accessory device to secure cameras. There are more and more visual sensors around us. We found them on smartphones, televisions, vehicles, and everywhere. This is probably because visual information plays an essential role to enable smart devices and smart home. They bring convenience to our daily life. But such convenience is at the cost of risking the privacy. Visual information can be very private. Many people like me are very concerned about the cameras on the ceiling. What are they actually doing? Will they upload the recordings to somewhere or someone that I'm not aware of? Unfortunately, these concerns are not fictions. Xiaomi, a major smart device vendor, probably due to protocol bugs, their cameras might leak images to other users. Another similar case is Nest camera. It is reported that some second-hand Nest cameras can be viewed by their former owner. Of course, the above issues were fixed, but the risks remain. There are much more undisclosed issues that can cause privacy breach. So, why such a problem haven't been addressed? Let's consider a typical use case. The camera of the device is recording. For some functional reasons, the recordings has to be uploaded to the internet. Encryption is a common way to secure the data outside of the camera, but it will fail if the camera operates incorrectly or has been compromised. Having a root of trust is the foundation for encryption to take effect. If the camera has been completely taken over, it is hard to enforce its software and hardware to operate as expected. Trusted computing hardware is a potential solution to this problem, but it cannot be applied to camera already in use. If there is no root to trust, then we can choose to trust nothing. It seems the Meta CEO does not trust his laptop and care about his privacy seriously. The camera of his laptop is taped and disabled physically. However, the approach is probably not suitable for people who still need to use their camera. We believe there shouldn't be such a stringent trade-off between privacy and functionality. And we want to find a solution that can protect the visual privacy against most threats and also retain the camera functionalities as well. Also, similar to installing an external lens, it would be better if the solution can be used to protect cameras already in use. To achieve the goals, we propose the CamShield system. To explain CamShield, we focus our discussion on widely used smart security cameras or smart cameras. The smart camera streams videos to a remote app. Many smart camera vendors also provide cloud services to improve the user experience. For example, cloud video analysis helps the user to identify strangers and tag activities in video stream. The CamShield device is a physical shield that can be installed in front of the smart camera. The smart camera can only capture the inside part of the CamShield. This prevents it from capturing the actual things. To preserve the functionality of the smart camera, the CamShield uses its own visual sensor to record real things. It encrypts the videos and transfers to the user. Simply put, our approach is to physically block the original camera and replicate its functionalities. A following question is why the CamShield is more trustworthy than the original camera. This is because we completely isolate the CamShield from the smart camera and the internet. It is a standalone device. This can effectively prevent it from many practical attacks. A second question is how will the protection affect the functionality of the camera? The CamShield uses its own camera to emulate the original camera. To support advanced features such as cloud analysis, it offers an option to the user to allow them to determine which part of the information can be disclosed to the cloud. CamShield is a hardware-software co-designed system. Here is the hardware architecture of the CamShield device. The rightmost camera is the smart camera to be secured. We use the lens to focus the smart camera to the screen. The screen is used as an output interface to convey information from the CamShield device to the smart camera. The processing unit manages the screen and the visual sensor. We prototype the CamShield hardware with commercial component and a 3D printed case. It can be flexibly adjusted to fit different cameras. Of course, the form factor can be further reduced and polished with engineering effort. Inside the hardware runs the CamShield software. The software can be divided into two parts. It first encrypts the captured video stream. Then it uses a special data path to convey the video stream to the smart camera, and then to the user over the internet. Next, we describe the two-part in detail. CamShield uses encryption to secure video stream. One direct way is to encrypt the entire frame, but this would completely destroy the video content and disable cloud analysis. Another choice is partial encryption. The advantage is that it can leave partial information for functional usage. For example, the cloud can still infer the motions or gestures from the video with the face area encrypted. We adopt partial encryption in CamShield. It allows the user to specify the area they would like to protect. These areas are called region of interest, or ROI. We use the latest computer vision algorithms to automatically detect the ROIs in video frames. Then the areas are encrypted accordingly. The user specifies the ROI areas by configuring the policies of the CamShield. For example, the time column and the enable column determine when and whether the corresponding ROI entry should be protected. To configure the policies, the user shows a QR code that contains the configuration message to the CamShield camera. Next, we show how the encrypted video is transmitted. For security reasons, the CamShield device is designed to be isolated from the network, but there must be a way to stream the video to the user. Any two-way connection, such as Bluetooth or USB cable, might bring breaches to the isolation. Further, as we also want to secure smart cameras already in use, the installation shouldn't involve hardware or firmware modifications. To meet all these needs, CamShield takes advantage of the visual sensing capability of the smart camera to establish a one-way data path. That is, the CamShield uses its screen as the transmitter and uses visible light signals to convey information to the smart camera. At a high level, the visible light communication works like scanning a QR code stream. The VLC streams looks like a QR code, but with colored blocks. We use 8 colors rather than black and white to increase the capacity. The VLC streams are displayed on CamShield screen and captured by the smart camera. Through decoding the captured VLC streams, the loaded video stream can be extracted. To decode VLC streams, the first step is to determine the location of color blocks. In practice, 2 types of distortions complicate the task. The first one is lens distortion. Pixels bent out from the center of the image. The other one is chromatic distortion. Different colors bend differently in the captured image. To calibrate these distortions, we introduce preamble frames before the data frames. The grid preamble is like a black and white chessboard to help us to localize actual block locations. And the color palette preamble allows us to calibrate the color channels. Then the color blocks can be precisely localized and the bit can be extracted. Here is a showcase of the entire system. The video stream is first captured by the CamShield device, and then it is encoded into VLC stream and displays on its screen. The VLC stream will be captured by the smart camera. So the smart camera, the VLC stream, is transmitted to the cloud server and the CamShield app. After VLC decoding, the cloud server can obtain the encrypted video and analyze the partial information. At the same time, the CamShield app can decode and decrypt to obtain the original video. In this talk, we propose the CamShield system to secure visual sensing devices. Its advantages are twofold. First, it is a bolt-on solution that turns a general camera into a trusted one without modifying hardware and software. Second, the trustworthiness of the CamShield is based on physical isolation. It is a standalone device. Its computing components are not only logically but also physically isolated from the network. Such isolation protects it against most practical attacks. Thank you, and I'm happy to take questions.